Good morning, students. Today we shall discuss volume integrals. Consider a closed surface S enclosing the volume V in a vector field A. So your vector field A is here. The surface is divided into large number of volume elements such as dV as shown in the figure. So where dV is nothing but dx, dy and dz, the product of all the three, dx, dy, dz. The volume integral of A over the entire volume B is represented by this formula. So we have triple integral with respect to volume A dV. So this is a formula that we are going to use for finding out the volume integrals, where A is given as this, and of course A vector A is given as AXI plus AYJ plus AZK. Similarly, we can also have the volume integral exactly like this. So we have the formula f dv. So instead of A, you can substitute, you can write any letters f dv, where dv is given as dx, dy, dz. Let us solve some problems. Scalar function f equals 2x deflected in the cubic. So this is a cubic that has been built by planes x equal to 0 to x equal to 1, x equal to 0 to x equal to 1. Similarly, y equal to 0 to y equals 3, and z equal to 0 to z equal to 2. So there are planes separated from the origin. So we have the origin. So those planes which are separated, the separation is nothing but, in terms of x is nothing but 1, in terms of y is nothing but 3 times. This plane is separated from origin, which is nothing but 2 times. Evaluate the volume integral f of the cubic. So we are going to evaluate using volume integral. And of course we know that f dv, which is the formula that we are going to use, and f is given as 2x. So f is given as 2x. So we have the volume integral. F is nothing but 2x. So 2x dx, dy, dz. What are the integrals? So the limits. So it's given as 0 to 1, 0 to 3, 0 to 2. So 0 to 2 in the z axis, 0 to 3 in the y axis, 0 to 1 in the x axis. So now you just pull 2 out. Okay. So integrating x will give you x squared by 2. You will have to use the limits 0 to 1. So we have used. Okay. So we have 1 by 2. You will have to substitute for x as 1. So we have 1 by 2 dy dz. And these two will get cancelled. So we have dy dz, correct? Dy dz. Integrate with respect to y, that will give you, we have y. So dy, so we will give you y. Limits will be 0 to 3. So substitute for y, you will have 3 dz. You pull 3 out. Integrating with respect to z will give you dz. So z, you will have to substitute 2 here. So 3 2s are 6. So f dv is nothing but 6. F is given as 2zi minus xj plus yk. Evaluate f dv with respect to volume integral. Volume, where V is a region bounded by the surfaces x equal to 0 to x equal to 0, y equal to 0, x equal to 0 to 2, y equal to 0 to y equal to 4. Then z equals x squared, z equal to 2. So with these limits which are bounded by the surfaces, we are going to find out the volume integral. So volume integral as per the limits, as per the problem. So 0 to 2, 0 to 4, x squared to 2. See here, we have 0 to 2. Then 0 to 4 for the y limits. And what about for the z limit? X squared to 2. X squared to 2. And f dv, f is given as this. dv is nothing but dx, dy, dz. Okay. So now let us integrate first with respect to z. So that will give you 2 z squared by 2 I vector minus xz j vector plus y z k vector x squared to 2 dy dx. So wherever you find z, you will have to substitute 2 first. Wherever you find z, you will have to substitute x squared next for the lower limit. So we have 2 will get cancelled. We have z squared, so that will give you 4i, correct? 4i minus, instead of z, you will have to substitute 2. So 2x j vector. So again z, for z, you will have to substitute 2, that will give you 2yk vector. Then minus, you have to substitute the lower limit. So that will give you minus, here 2 will cancel, already we know, and this is z squared. So x squared whole square, that will give you x to the power 4. So minus plus, it will become plus. So we have, instead of z, you have to substitute x squared. So that will give you x cube. Instead of z, you have to substitute x squared. So minus x squared y dy dk. Now we can integrate with respect to y. So integrate with respect to y. So that will give us 4y. See here, 4y. This will become 2xy. This will become y squared by 2. x4y. This becomes x cube y. This becomes x squared, already y is set. So y squared by 2. See, y squared by 2. Is it okay? Simple. Now you have to substitute the limits 0 to 4. So substituting the limit, that will give you, already 4 is there, so we have 16i. So this becomes 2 4s are 8, so 8xj. 4 squared, these two will get cancelled. We have 4 squared, so this becomes 16k vector. Minus, you have, instead of y, you have to substitute 4. So 4x to the power 4i vector. Instead of y, you have to substitute 4. So 4x cube. Minus you have 4 squared, so 16 by 2, which becomes 8. So 8x squared k vector dx. Now you have to integrate with respect to x. Okay, so that will give you 16x minus 8x squared by 2, 16x, x to the power 5 by 5, x to the power 4 by 4, x cube by 3. Now you have to substitute the limits 0 to 2. So that will give you 32. Here it is 4. Already, so 2 squared 4, so 4 4s are 16. The next one will be 16 multiplied by 2, that will give you 32. Okay, then here it will be x to the power 5, so 2 to the power 5. So 2 to the power will multiplied by 4 will give you 128 divided by 5, and here it is 2 to the power 4 multiplied by 4 will give you 16. Here 4 will get cancelled. This 4 and this 4 will get cancelled. 2 to the power 4 is nothing but 16, and here it is, last one is 2 to the power 3, which is nothing but 8. So 8 multiplied by 8 divided by 3, which is nothing but 64 by 3. Okay, so now 32i, this 32i minus 128, we can take the LCM. 16 minus 16j plus 16j will get cancelled. So we have 32k minus 64k. Take the LCM. So there is no jth component. We have only ith and kth components. So simplifying, that will give you 32 divided by 5 I vector, 32 by 3 k vector, which is nothing but the answer for the volume integral. Okay. Now we'll solve the next problem. So f is given as this: 2x squared minus 3zi plus 2xyj minus 4x k vector. Evaluate del cross f dv. So triple integral del cross f is asked, where v is the region bounded by the plane x equal to 0, y equal to 0, z equal to 0, and the plane equation is given as 2x plus 2y plus z equal to 4. Okay, so first you just divide this plane equation by 4. That will give you x by 2, y by 2, z by 4. Okay, so it means we have the x-axis, y-axis, z-axis. Okay, x by 2 means it cuts at the x-axis at 2. It cuts at the y-axis at here. And it cuts the z-axis at 4. So that's why 0, 0, 4, 2, 0, 0, 0, 2, 0. The limits will be as usual 0 to 4, 0 to 2, 0 to 2. So you can find out. We'll find out. What are the limits, we'll find out. So what is asked? Del cross f is asked. Okay, del cross f dot dv. First we will find out del cross f. So del cross f is nothing but, as usual we know, ijk partial d by dx, partial d by dy, d by dz, and f is given as this. So simplification, we have dy by dy times minus 4x. So there is no y here. So answer is 0. Here there is no z here, answer will be 0. Minus j, we have this one and this one, that will give you minus 4. And this one and this one will give you minus of minus 3, that will give you plus 3. And the last one is, we have last one, which is nothing but k times minus 2y minus 0. So we have del cross f is given by this. Okay, so we have del cross f is given by this. So triple integral del cross f dv is given by this expression. Now let us find the limits now. So we know the equation 2x 2 plus 2y plus z equal to 4. So first you substitute as usual what we have done in double integral. First you have to go with z equal to 0. So when you are going to have z equal to 0, we have 2x plus 2y equals 4. Dividing by 2 will give you x plus y equals 2. So therefore y equals 2 minus x. Okay, so y equals 2 minus x. So therefore z equals 4 minus 2x minus 2y. We'll see. So we have now y goes from 0 to 2 minus x. Y goes from 0 to 2 minus x. And of course x goes from 0 to 2. 0 to 2. 0 to 2. And what about z? Z is nothing but 4 minus 2x minus 2y. So it goes from 0 to 4 minus 2x minus 2y. See, 4 minus 2x minus 2y. The limits are as it is. Now we have the integral. As usual we have integral. We are going to integrate now. So first we will integrate with respect to z. So we have now z minus 2yz. Integration goes from 0 to 4 minus 2x minus 2y. So wherever you find z, you have to substitute the upper limit and the lower limit. So we have now, instead of z, we have 4 minus 2x, see 4 minus 2x minus 2y j vector minus 2y. Instead of z, you have to substitute 4 minus 2x minus 2y k vector dy dx. Okay. Now the next one is just multiply 2y inside in the second expression. So we have 2 4s are 8y. So we have 8y minus 4xy minus 4y squared k vector. Okay. Now let us integrate with respect to now y. We have integrated with respect to z. We are going to integrate with respect to y now. So that will give you 4y 2xy y squared by 2 y squared by 2 y squared by 2 y cube by 3 y cube by 3. Okay, so as usual you have to substitute 0 to 2 minus x for the limits of y. So instead of y you have to substitute the upper limit and the lower limit. So let us substitute. So substituting that will give you, and I have written the same equation, and substituting that will give you 4 here, 4 times 2 minus x minus 2x times 2 minus x. So minus 2 minus x whole square of j. Then minus, you have 4 is there. Instead of 4 you have to substitute 2 minus x, so 2 minus x whole square minus 2x 2 minus x whole square minus 4 2 minus x whole cube divided by 3. So now 2 minus x is common here. So here, so I am going to take 2 minus x common in the first expression. So we have now 2 minus x here, here also 2 minus x. So I have taken 2 minus x common. Remaining will be 4. Here it is 2 minus x, see, minus 2x. Is it okay? Everyone? Here I have taken 2 minus x common. The remaining thing will be 4 here. Here it is remaining thing will be minus 2x. And here let it be like this. And here also I can take 2 minus x common out. So we have 2 minus x whole squared as common. So we have 2 minus x whole squared. The remaining one will be 4 minus 2x. This time let it be like this. Okay. So now we can pull 4 minus 2x, we can pull 2 out. So in this expression we can pull 2 out. So that will give me 2 minus x, correct? And here also 4 minus 2x, you can pull 2 out. So that will give you 2 minus x. Now 2 minus x is there. So 2 minus x whole squared. I can pull 2 minus x whole squared out. Is it okay? I repeat, 2 minus x is here. Here also we have 2 minus x. So 2 minus x whole squared. Here we have 2 minus x whole squared. We can pull 2 minus x whole squared out. So that will give you 2 times. Okay. So we can write like this. 2 minus x whole squared minus 2 minus x whole squared. And here you have 2 minus x whole squared, 2 minus x. So we can write 2 minus x whole cube. So here we can pull 2 minus x whole squared out. Here we can pull 2 minus x whole cube out. Is it okay? See here 2 minus x whole is common. Here 2 minus x whole cube is common. So we can pull 2 minus x whole squared out, 2 minus x whole cube out. Okay, I have written the same thing here. I have pulled 2 minus x whole squared out. Remaining term will be 2, and this one is 1. So minus 1. Is it okay? And here 2 minus x whole cube common. The remaining term will be 2, and here the remaining term will be minus 4 by 3. So we have 2 minus 1, that will give you 1. So 1 time 2 minus x whole squared as it is. 2 minus x whole cube is there. 2 minus 4 by 3 will give you 2 by 3. 3 2s are 6. 6 minus 4 divided by 3, that will give you 2 by 3. Okay. So we have now this term we are going to integrate with respect to x. So that will give you 2 minus x whole cube divided by 3. This minus 6 so minus 1. So that is minus 3. And similarly here 2 minus x whole to the power 4 divided by 4. Here minus is there, so minus 4. Okay. Now this minus I have pulled out here, minus minus plus. And now you have to substitute for x. Okay, the limits. So I have written the same thing here. You substitute the limit, that will give you, here it is, first you have to substitute the upper limit. 2 minus 2, 0. See, 2 minus 2, 0. The answer is 0. You will have to substitute lower limit. When you are going to substitute the lower limit, that will give you 2 minus 0, 2. So 2 cube. 2 cube is nothing but 8 by 3. Is it okay? Similarly, you are going to substitute 2 first. So 2 minus 2, that will give you 0 here. So 0. Then again you will have to substitute 0 here. So 2 to the power 4. So that will give you minus 16 by 4. Is it okay? Now minus minus plus. So 8 by 3 times j minus, here it is nothing but 4 times 4 multiplied by 2 will give you 8 by 3. Okay, plus into minus, that will give you minus. So we have 8 by 3 k. So this is the answer. Del cross f is asked. So we have found the del cross f, which is nothing but 8 by 3 times j minus 8 by 3 times k vector. So that's all. So let us evaluate the next problem. 2x squared 2x squared yi minus y squared j plus 4x z squared k. We evaluate del cross f. So last time we were asked to calculate del cross f. See here, del cross f. So this time we are asked to calculate del dot f. Del dot f. Del dot f dv. Bounded by x equal to 2, y squared plus z squared equals 9. So f is given as this. Del dot f is asked. So del dot f equals partial d times x term, partial d by dy over jth term, and partial d by dz kth term. So that will give you 4xy, correct? This becomes minus 2y, correct? Minus 2y. This becomes 2z. So 2 4s are 8. That will be 8xz. So del dot f is nothing but this. So del dot f dv. So del dot f dv. dv is nothing but dx dy dz. So dz dy dx. What are find out the limits? What are the limits? It's given as x square y square plus z square equals 9. First you substitute z squared equal to 9 minus y squared. So z equals 9 minus y squared to the power 1 by 2. Root 9 minus y squared. Okay. So the limit for z will be 0 to root of 9 minus y squared. Okay. The next one will be y square plus z squared equals 9. Putting now z equal to 0, y will be 3. So 0 to 3. Okay. So as I said, 0 to 3, 0 to root of 9 minus y squared. This is for z limit, and this is for y limit, and this is for x limit. See, x limit. X limit is given as x equal to 2. So it implies that 0 to 2. 0 to 2. Is it okay? So 0 to 2, 0 to 3, 0 to root of 9 minus y by 2. This will be your del dot f. This is nothing but dv. First we will go for the first integral dz. So this becomes 4xyz. This becomes minus 2yz. This becomes 8x z squared by 2. We are going to integrate with respect to z. So this becomes z, we have z squared by 2. The limit will be 0 to root of 9 minus y squared. So wherever you find z, you will have to substitute the upper limit and lower limit. Substituting the upper limit will give you 4xy root of 9 minus y squared minus 2y instead of z root of 9 minus y squared, correct, plus a plus this 8 by 2, that will give you 4. So 4x 9 minus y squared, z squared is there, so the root will go up, so that will give you 9 minus y squared dy dx. Now see here, root of 9 minus y squared is common here, you can pull it out, so that will give you root of 9 minus y squared, we have pulled out. And here also we have 2y, here 4xy, we can pull 2y out, so that will give you 2y root of 9 minus y squared. The remaining one will be 2x, the remaining term will be 1, so 2x minus 1 dy dx. And here it is as it is. Now we are going to integrate with parametric form. This is called a parametric equation. So let t equals root of 9 minus y squared. So t squared will be 9 minus y squared. Just differentiate, that will give you 2t dt, which is equal to minus 2y dy. So wherever you find 2y, you have to substitute minus 2t, 2y dy. See, 2y dy, we can substitute minus 2t dt. See, 2y dy minus 2y dy is nothing but 2t dt. So 2y dy is nothing but minus 2t dt. So minus 2t dt. Okay, this is nothing but, this can be replaced with t. So t is here. We have 2x minus 1 as it is. Plus, wherever you find 9 minus y squared, see 9 minus y is nothing but t squared. So we have now, this term 4x, we have now, we can integrate easily. This one we can integrate with respect to y easily. See here, 9y, y cube by 3. But this is very difficult to integrate. That's why this is under root. It's very difficult to integrate. So that's why we have gone for parametric solution, parametric equation. Straight away we can integrate. Here as it is 4x, we have 9y minus y cube by 3. You can substitute for y as 3. But here it is root is there, root of 9 minus y squared. So that's why we have used parametric form. So we have now this one. And when you are going to use t equals root of 9 minus y squared, we will have to change the limit too. We should change the limit. So when y equal to 0, what are the limit? Y equal to 0 to 3. When y equal to 0, you substitute y equal to 0 here. Y equal to 0 means t equals 3, root 9. When y equal to 3, upper limit, when y equal to 3, t will be 0. So the limits will be changed 3 to 0. Is it okay? So earlier 0 to 3, this is in terms of y. Now 3 to 0, this is in terms of t. See here we have t. Okay, earlier this is y. This is with respect to y, 0 to 3. Now you have changed the limit. Wherever you find y equal to 0, t becomes 3. Wherever you find y equal to 3, t becomes 0. So instead of 0, you have to substitute 3. Instead of 3, you have to substitute 0 here. This is in terms of t. Now I can change the limit and I am going to remove the minus sign. I can change the limit. I am going to interchange the limit and remove the minus sign. So I have removed the minus sign. Now 0 to 3. Is it okay? See, I have changed the limit now. And remove the minus sign. See, I have removed the minus sign. Now 2 is there. We are going to integrate this t, and this t will give you t squared as it is like this. And this becomes, you can substitute for y. So that will give you 9 3s are 27. So 27 minus 3 cube, which is nothing but 27 by 3. 27 by 3 is nothing but 9. So 27 minus 9. 4x multiplied by 18. So that will give you 72x dx. Easily you can integrate. Now we will come to this side. So we have 2t squared dt, 2x minus 1 dx. Okay, 2t squared dt, 2x minus 1. So you will have to integrate with respect to t, that will give you t cube by 3. The limits will be 0 to 3. So wherever you find t, you have to substitute the upper limit So that will give you 3 to the power 3, which is nothing but 27 by 3. 27 by 3 is nothing but 9. 9 multiplied by 2 will give you 18. So 18 multiplied by 2x minus 1 dx. Now it's easy to integrate with respect to x. So this will give you x squared by 2. This will give you x squared by 2. So I have written the same thing. So this will give you x squared by 2. Correct? And this is nothing but x squared by 2. Now instead of x you will have to substitute 2. So that will give you this 2 will get cancelled. That will give you 4 and 4 minus 2. 4 minus 2 is nothing but 2. So 2 times 18 will give you 36. And here it is 4 by 2 is nothing but 2. So 2 times 72 will give you 144. So 36 plus 144 is nothing but 180. So we will start today. Thank you students. We will see you in the next class.